Hello again. This is the second half of the chapter. So the first half of the chapter is the confidence interval for a mean. Okay? And we had 2 videos on that. They were similar, but a little bit different. This is the second half of the chapter. Now I have one other video that you'll watch that will be useful for later, but really this is the second half. And here is the problem. It says, what percent of high schoolers are excited to return to school at the end of summer? So I probably don't want to go around and ask every single high schooler in America. That would take forever and probably lots of money. And so I decided to take a sample. Okay, so in this case, I took a sample of 2,600 high schoolers. Okay, hopefully it was done randomly. Hopefully I didn't just go to one state in the United States. Hopefully I randomly selected them, which could be difficult to do, but let's suppose I did it. Let's suppose I got a sample percentage. What percent do you think are excited to come back to school? Let's find out. This is actually true. 74. Almost 3 out of 4 high schoolers are actually excited to come back to school. I know you're excited to come back to school. And we're supposed to construct and interpret a 95% confidence interval for the proportion of students who are excited to return. So hopefully you are thinking, all right, I got to go through a 4-step process. Well, you would be right. Here we go. Step 1 is the name. Step 1 is the name. This is still a 1 sample. That means I took 1 sample. We're only doing 1 sample now. We'll do 2 sample later. So this is a 1 sample. And I'm going to throw a letter in there, and it's not super important now. I'll try to talk about it later. And it's the letter Z. Okay, proportion is Z. Okay, proportion is actually a normal curve. Okay, so 1 sample, Z, interval, and it is for a proportion. Okay, and you could say this different ways. The order doesn't matter. You could do 1 proportion Z interval. Okay, you don't really need the word sample. I just wrote it all out there. You could do 1 proportion Z interval. I think that's kind of what our calculator does. But you need to have the word proportion, need to have the word 1, and need to have the letter Z in there. And that's step 1. Step 2 is, where did we get this data? It does not say. Did I randomly select them or not? That is important. You want to tell AP, you want to tell me that that's what you're looking for. So in this case, I guess we would just say assume a simple random sample. And then we need to have the normal check. You cannot use the central limit theorem for a proportion. You cannot use it for percentages. You can only use it for means. So this one is not the central limit theorem. That's a big difference between these problems. We actually had it last semester. To check for normal for a proportion is you have n times p greater than or equal to 10 and n times 1 minus p greater than or equal to 10. They want you to plug in the numbers and check. N is the sample size. How many high schoolers did we ask? I believe we asked 2,600. P, I guess it's technically P hat, so I'll do that. It's the sample proportion, and that was 74%, so 0.74. And we're going to check to see, is that greater than or equal to 10? I have a calculator here, I'm sure you do. I know it's well above 10, but let's do it. 2,600 times 0.74 is 1,924. And yes, that is well above 10. And then 2,600 times 26%, 1 minus p hat. And I believe that is 676, I believe, which is well above 10. So we'd need to do that. This is the normal check. So we'd want to say, therefore, it is approximately normal. Okay, this is also showing, did I have a big enough sample size? And yes, I had a big enough sample size. I can use the normal curve. There it is. Okay, so that is your normal check. We always want to look for where do we get the data from. We'll assume a simple random sample. You can't do that in real life. Okay, but we'll do it. And that's step 2. Step 3 is the calculator step. The calculator will do the work, but what is it doing? It's saying, hey, we're going to take our guess. Our guess is our sample proportion, which is 74%. We think 74% of high schoolers are excited to come back to school in the fall, but I'm sure it's not exact. So we're going to have a plus or minus a margin of error. That's what the calculator is doing. So let's punch it into our calculator. So we're going to hit stat and go over to tests. And we're looking for a 1 proportion z. So we're going to add a new one here. We, I believe, have done number 8. We're not doing that one. Mean is for t intervals. So we're looking for a 1 proportion z interval. 1 proportion z interval, and I guess that's the letter A. So we'll hit this one. So let's see. I'm going to start with the easy one, the confidence level. And I believe that they want us to do a 95. So let's do a 95.95. If you do 95 and not the decimal point, it's going to cause problems. N is the sample size, 2,600. And X is the amount of high schoolers that said, yes, I'm excited to come back. Now, I believe that it actually didn't tell us that. Sometimes it will, but it actually gave us the percentage. So we actually have to calculate the percentage, which is not that difficult. You take 0.74 times 2,600, and we get 1,924. That's the amount of students, high school students, that said yes. You take 74% of that. Okay, so you enter in the numbers. 0.74 times 2,600, that's how I got this number. And then you just go calculate. Bada bing, bada boom. Between 72.3% and 76%. So 0.723. Come on, there we go. 0.723 and 0.757. Oops. 0.757. Okay, that's step 3. Use our calculator correctly. Step 4. We are 95% confident. And again, you can go back and look at it. Go back and look at that last sentence. We are 95% confident that the true proportion of students who are excited to return is between, okay? Go back and look at it. You almost can copy it down. You got to chuck in maybe a word or two. We're 95% confident that you could write population proportion, but I'm going to write the word true. The actual proportion, again, proportion means percent. Proportion of high schoolers that are excited to return to school is between 0.72 and 0.76. So we're pretty confident that between 72 and 76% of high schoolers are excited to return in the fall in a normal year. And that's the four-step process, okay? What does 95% confident mean? What does the interval actually mean? You do not put this on your four-step process, but it's a great multiple choice question. It means if I do the same procedure many times, I ask 2,600 random high schoolers, and then I do a confidence interval, that 95% of those confidence intervals will capture the true proportion. That's what a confidence level means. You do not put it on your four-step process. It's a beautiful multiple choice question. But this is your four-step process. And really the only difference is you have to be able to punch the numbers in correctly into your calculator. The normal check, you cannot use the central limit theorem. You do not graph any data. It's n times p, n times 1 minus p. Yes, you have to plug in the numbers. Yes, you need to say it's approximately normal. And the name is obviously different. But other than that, it's similar to the other ones. And that's basically the chapter. Now, I have another video that we'll watch that's similar, but you have seen it. It's one sample mean, one sample proportion, confidence interval, go through the four-step process, and that's it. Do I have a joke? By the way, hopefully you looked at this at the beginning. They spelled out the word school, and they did it incorrectly. So I have some funny signs, if you care to watch. Oh yeah, I did that, good. Invincible moose, next 5 kilometers. Ha ha! And then this says, the Shed Cemetery Drive, dead end. Ha ha! All right, have a good day.